Hello, I am Eduardo Ximenes from the PrimeCorn project, and I'm here today to present Deliverable 4. For this week, we are delayed by 1 hour. We had planned 24 tasks and had completed 18 of them. This week we worked 55 hours, but had planned 71. This difference is caused because we have planned five tasks which are related to the risk response plan, and we had proposed to create a data set from scratch, but that wasn't necessary. Today we have two main parts to present. The first of them is the software diagrams updates. In the diagrams we have two main points which are related to the time passed and deactivating the motors, turning them off. So in the beginning of the project, if the first seed wasn't detected and 15 seconds was passed, we turn off the motors. And here, if the laser sensor doesn't detect a seed, in 15 seconds we turn off the DC motors too. This was the expected behavior, but we didn't include in the last week. So here are the updated diagrams. For the second part, I'm going to show you the expected, which is related to the software project. The first part, it's the app and it related screens. Here we have the mobile preview. This is the home screen where we have the past projects. Each of them is stored as an item like this, rectangle, where we have the date, the total seeds, the percentage of regular seeds of the project, of the process, and the irregular. Here we have the irregular. And it related proportion of seal cuts, colored, or broken seeds. Besides that, we can refresh the page, and here we have the sync option. Down below we have the sync option, which we can use to find the machine and sync. If we click in the connection button, we will be redirected to the connection screen, and the related data will be transmitted to our app. Now I'm going to show you the simulated environment for the Raspberry Pi Pico, where we have tested the firmware. First of all, we boot the project, the Raspberry Pi, and we can see on the screen of the PC the status. First we are going to run, and we can see the boot to idle stage. After that, we have simulated the process of syncing your phone. So as I am going to show you, you can see the idle to sync and the sync to idle, which is related to the process of connecting your phone to, sorry, not connecting your phone, which is the process of connecting the Raspberry Pi 4 to the Raspberry Pi Pico. After that, we have the button where we can press and show that the process has started. And here on the screen you can see the idle to ready stage. I'm going to show again the idle to ready stage, and then we can see the motors starting and working. After that, if the laser sensor detects a seed, the LED indicates that the process has begun, and after the detection, we see that the servo motor rotates to another side, and again, and that is shown on the terminal, which we show that the first seed was detected. After that, so here after 15 seconds of the second seed is detected, the process finishes. So the DC motors are going to stop. Here it's a blue LED which indicates that the data is being stored of this process. Then after that, it shows on the terminal that X seeds were detected. Then it shows that it was in the state processing to saving. Then from saving to idle. And now when you are in the idle state, you can press the button and start a new project again, a new process again. So this is what is showed here. Alright, so after that, after all those tests, we have the Raspberry Pi 4 backend test, where I will show the image taken by the USB camera. This is the resolution which we have acquired, which we have achieved. So then after that, we have passed this in a Python file, a script where we can crop the image and make it more clear and more precise of what we are processing, right? So this is the pre-processed image, which will be sent to the computer vision model and will be classified. And here we have the USB camera that we have used, which have adjustable focus and has helped us to take in this type of image and this quality too. For the end, I have the following. So here I'm going to show an example of sending the process from the Raspberry Pi, which is the server, to the cell phone. Here we have stored 3 processes, 3 past process, and I'm going to show you how we initialize the server. So this is the get server which we are using. So after we initialize it, we can come to the mobile app, which is empty, so we don't have nothing in the home screen. After that, we click on sync, we click on connect, and here it's the Raspberry, which is simulating the machine, right? After that, we click on the Raspberry, and the app starts to sync. It will be displayed on the terminal. This is the first data. It has a process ID, which classifies each one of them. So now we wait to the sync process. After the sync process, we can see that the database which we are using, which is a JSON file, is automatically empty. So we have transferred the data from the Raspberry to the cell phone, and after that the data is erased, right? So this is showing here. And after that we can see the data which was passed from the Raspberry and is now being displayed in the welcome screen of the app. So these are the 3 processes we had there. And besides that, we have the detailed view of each process, which shows the data, the percentage of irregular seeds, and here a more detailed view of each irregular seed type. So we have the seal cut, scoured, broken, and the unknown. Okay. And to finish, we have the integration. So here we have the firmware, and we have the Raspberry Pi 4, we have the Raspberry Pi Pico, we have the servo motor, and the process of taking the picture. So what I'm going to show you, it's the following. We have booted both Raspberries, and after that we're going to see the red light, which indicates we are in the idle state. After that, after pressing the button, we have the processing state, the ready state to be more precise. When we detect a seed, we have the processing state, the motor is working, the servo motor doing what it has to do. which is detect a seed, take the photo, and after that classifies it as a regular or irregular. And as I said, when the seeds pass through the laser, it has to take in a picture, and this is what we have here. So I'm going to show again. As I said, after the seeds pass, it takes a picture. The servo motor rotates again, another seed, or as it's happening here, just a finger passing through the laser. But that's the concept. You have the laser sensor activated, and then a picture is taken. So for this deliverable, this is what we proposed to do, and we have done and worked for the past week.